All right, so today we're going to talk about area in polar coordinates. So this is an example that I was asked to solve. It's from a worksheet. So the original in the worksheet has some slightly different numbers, but it's going to be basically compute the area of the inner sector or the inner area of the function r equals, I want to do 1 minus 2 cosine of theta. Now, the problem in the worksheet is actually 3 minus 4 cosine of theta. But the ideas are the same, except my solutions are going to be a little bit nicer just because I can use the unit circle to find the roots of the equation I want to set up. Now, if you have 3 and 4 or whatever two numbers, all you have to do then is use an arc cosine and you end up with decimal positions, so decimal numbers. So it's not going to be as pretty, but it will work. So the first thing you want to do when you want to solve these kinds of problems is, well, first thing you would want to do is to graph your, seems like that marker was a little bit, oh yeah, this is better. Try a different marker, see if something looks a little nicer. So I'm going to make a table with my angles and my radii that I'm going to compute. I'm going to do a few. So start at 0. When you plug cosine of 0 here, you get a 1 times 2, negative 2, or 2. 1 minus 2 is going to be negative 1. So we're going to plot this over here. I need a little bit more room. This direction, 1, 2, 3. I need to go all the way to 3. I want to plot a point. So this right here is the first point. Angle 0, radius negative 1, so I go in the opposite direction, negative 1. All right, so then I want to move on to, say, pi over 6. Actually, let's do pi over 4. So when I plug pi over 4 here, and that, by the way, that angle is going to be in this direction, pi over 4. When I plug pi over 4 here, I get square root of 2 over 2. So I'm going to have 1 minus square root of 2. Now the square root of 2 is 1.4 something. When I do 1 minus that, it's going to be a negative 0.6 or 0.59 or something along those lines. It doesn't have to be exact, but let's go ahead and graph something that is between 0 and 1 and in the negative direction. So I'm going to be somewhere out here. And then I want to go to pi over 3, the one I want to do. And that's because pi over 3 is special, because cosine of pi over 3 is going to give me 1/2. I'm going to have 1 minus 2 times 1/2, 1 minus 1. I'm going to get 0. So you see, that is going to be drawing my first. So between 0 and pi over 3, I get this part of the graph. Okay? All right, so now I'm going to continue, and I'm going to go all the way to, say, pi over 2. At pi over 2, the cosine is going to be 0, so I get 1 minus 0, so I'm going to have 1. So I'm going to be going up to 1, so let's go ahead and mark this out. Roughly there. And the next point I'm going to end up with is this one. So technically I have to plot some point in between, but you can imagine this is going to have to come out here and continue like that. All right. Now I'm going to go ahead and plot another point. So for example, I could do 3 pi over 4. Actually, 2 pi over 3 is going to be important as well, because I'm going to be doing the cosine of 2 pi over 3, which is going to be a negative 1/2. So whenever I get a negative 1/2 times 2 is going to be negative 1. 1 minus negative 1 is going to be 2. So the angle pi over 3, 2 pi over 3 is going to be going somewhere out here, and I'm going to be going 2 units in that direction. So I'm going to be somewhere following like a circle, roughly here. Sure, sort of, yeah. And so my graph will continue like that. Now I want to plug in pi from here. There's other points, but pi is going to send me down to here, as you'll see. I don't know if I can fit it here. I'm going to continue my second part of the graph on this side. just in case, because last time I eliminated a bunch of points I didn't even notice. But that. So pi, I get cosine of pi is -1, so I get 1 minus -2, which is going to be +3. And then that is going to send me in the pi angle 3 units to, well, in this case, the left, because I'm going to be measuring an angle of 3. So that's going to be this first part of my limacon. That is given by that graph. All right, so I can continue like that, and I will just pause for 1 minute when I get back to this point right here. And that is going to happen, well, let's go slowly. 5 pi over 4. I don't want to jump too much. So 5 pi over 4, one more point before we get to that. When you put 5 pi over 4, the cosine here is negative square root of 2 over 2. So you're going to have 1 plus the square root of 2. And that's going to be 2.4 roughly. So in this direction, this angle, measuring 2.4, 1, 2, 2.4, continue sort of in a circle. So my point should be, if I have any sense of what a circle looks like, which I don't, should be there. All right, so that is going to be my next part of the limacon. Continue like that. And then I'm going to go to the one I was talking about, which is going to be what is 4 pi over 3. I don't know why I was blanking on that. So pi over 3, and so pi, another pi over 3, 4 pi over 3. And when you plug that, the cosine is still -1/2. So you get 1 minus -1, which is going to be 2 again. So this one is going to send me here 2. The angle is going to be somewhere here. That's not the one I wanted to plot, but now we're here. So let's plot that one as well. Continues. The next one I want is the next multiple of pi over 3. But to get to that, I have to do 3 pi over 2. 3 pi over 2 is going to send me to cosine of 3 pi over 2 is 0. 1 minus 0 is 1. So I'm going to have that next point, which is going to be here at 1. So overkill here. All right, and finally, pi over 3 past the 3 pi over 2, or 2 pi minus pi over 3, which is going to be 5 pi over 3. And that when you plug that one, 5 pi over 3, you're going to get that this is going to be 1/2, and you're going to end up having 0 when you evaluate it. I don't think I can fit it in my table, but at that angle of 5 pi over 3, you end up here back at 0. Now, if you continue your table, then you're going to get this. So your options are to compute this little area that is the one we want. You can do it in 2 ways, sort of. One way could be grabbing this first part that we did here and setting your integral up from 0, from 0 to pi over 3. That would go from here to here. That would give you one part of the interior. You could multiply that times 2 using the symmetry, or you can set up your integral a little bit different. So what am I going to do? I want to start here at 0, and I want to try to go around this way. So what angle, or for what angle am I here? So to do that, I need the radius to be 0. So if I set the radius equal to 0, I get 0 equals 1 minus 2 cosine of theta. Sorry, I cut that off. When I solve this, I can add the 2 cosine of theta on both sides, and I get 2 cosine theta equals 1, from where I get that cosine of theta is equal to 1/2. So you go look in your unit circle, and you're going to have 2 points for which that happens. You're going to have pi over 3, but you're also going to have then your 7 pi, which one did I say? 5 pi over 3, sorry. I think 7 pi over 6. 5 pi over 3, and that will not help you, because your problem, or your intuition, or your first desire would be just to set up your integral, say, from pi over 3 to 5 pi over 3. But if you notice, pi over 3 to 5 pi over 3 would draw this part. and you would end up computing the outside of the limacon. Okay, so what you're going to notice is that that 7 pi over 3, when you subtract 2 pi to it, is going to give you negative pi over 3. And then that's when you can set up your integral. So I'm going to erase this, and with these 2 points, now the negative pi over 3 starts here, then all the way when you go to 0, it's going to draw this part. When you get to 0, is what we drew. From 0 to pi over 3, finishes drawing the rest. So you can go ahead and compute your whole integral from going from negative pi over 3 to pi over 3. All right, so now let me go ahead and erase this, and I'm going to set the integral and when I compute it. So I'll go ahead and do that. All right, so at this point, we want to remember what the formula for the area is, and it's going to be 1/2 the integral from the angle alpha to the angle beta of the function of the angle, that's the radius. In our case, oh, I forgot to erase everything. This is going to be our radius squared d zeta. So in our particular case, we can do 1/2 of the angle from the integral, from negative pi over 3 to pi over 3 of this function, which is the radius, 1 minus 2 cosine of the angle squared d theta. So now it's just a matter of computing the integral, and we will go ahead and work through the details. I'm going to erase this now that we got it, and we'll just use the whole board to compute the integral. All right, so I'll be right back. All right, so let's go ahead and do this. So we start with 1/2 of the integral. So when I FOIL this out, firstly, square of the first minus the double product. So it's going to be 2 times 2, so 4 cosine of the angle plus the square of the second. This marker is really bad. I'll be right back. I'll get a better one. All right, so hopefully this one is better. So what I'm going to do then is I'm going to go ahead and start integrating the easiest one. So for example, the 1/2 here, sorry, the 1/2 I'm going to integrate. I'm going to have 1/2 of just theta that is evaluated between these two quantities. So I'm just going to end up with pi over 3 minus negative, so plus pi over 3. And then I'm going to have this integral right here. So that's going to be 4 divided by 2. The integral of the cosine is just the sine. I'm going to leave that one indicated from negative pi over 3 to pi over 3. I don't know if I can fit it down here, so I'm going to continue, kind of ugly, but plus 1/2 of the integral between negative pi over 3 to pi over 3 of the 4. So maybe I should have pulled this 4 out and multiply times 1/2 and make it just 2. Let me erase that and just make it 2 real quick. There, better. And then I'm going to have the cosine squared that I'm going to then substitute with 1 plus cosine of 2 theta over 2 by the half angle formula. Remember that integral of the square necessitates the half angle formula, and I think it just got cut off. Sorry about that. I didn't want to put it here to not cut it off, and I cut it off there. My goodness. Anyway, so here I have 2 pi over 3 divided by 2, so it's going to be a pi over 3 overall. Now here, the sine of pi over 3 is the square root of 3 over 2, and the sine of negative pi over 3 is the negative of it. So I'm going to end up with 2 times the sine of pi over 3. That's just because sine is an odd function and you're integrating between negative a and a. So you can just multiply times 2 times one of them. So I'm going to end up with then minus 2, the square root of 3. Because square root of 3 over 2 will cancel these two, but I get it twice. And then plus this integral So I'm going to go ahead and divide this 2 with this 2, and I'm going to have just the integral from negative pi over 2, 3, I said, to pi over 3, sorry about that, of the 1 plus cosine of 2 theta. Can I fit that d theta? Sure I can. On my board it fits. I don't know if it fit in the camera. Hopefully it did. So I'm going to have pi over 3 minus 2 square root of 3. I'm going to try to write that small because we don't care about that really. Now here, the pi over 3, again, I'm going to be integrating that 1. So I'm going to have theta between negative pi over 3 and pi over 3. So it's just going to give me 2 times pi over 3. So plus 2 pi over 3. So I'm going to skip that one a little bit, but just because I know that those you are more comfortable doing already. But these ones, maybe you have forgotten how to do it. So the cosine of 2 theta, you need to do a u substitution. By the way, do you know how a mathematician breaks up with their significant other? They say, I'm making a u substitution. Anyways, terrible joke, by the way. So here I'm going to integrate. I like it. So let's collect this. 2 pi over 3 plus pi over 3 is going to be pi minus 2 root of 3. And then here I'm going to have to then integrate. When I do my u substitution, u equals 2 theta, I get a 1/2 that comes out. I integrate the cosine, I get a sine of 2 theta. If you don't like what I did here, please pause right now. Do your u substitution. U equals 2 theta. Du is 2d theta. Divide by 2 on both sides. Make the substitution. Make sure that you agree with me. But now you're going to evaluate between negative pi over 3 and pi over 3. The sine of, in this case, is going to be 2 pi over 3. Is going to give me, well, let's copy everything. Again, sine of 2 theta is still going to be an odd function. So I still can do 2 times this integral, or this sine, sorry. But we'll get to that when we get to it. Not yet. Root of 3. So now this one plus, and I'm going to have the 1/2 sine of 2 pi over 3. That would be 1/2 of the square root of 3 over 2. But I'm going to do it twice. So I'm going to have plus square root of 3 over 2 in total. So that's what I'm going to get for this part when I evaluate it. Of course, you can pause and make sure that you agree with me. And if not, you let me know in the comments that I made a mistake. Minus 3/2 of the square root of 3. And that's going to be the area of that little sector of the limacon. So in this case, the more difficult bit of the problem was determining your endpoint for your integral. But nonetheless, once you determine that, the integral was not too difficult, a couple half angle or 1/2 angle formula, but I think you are more comfortable with that already. So anyways, that was a quick video because I was asked the question. So thank you for watching. And if you have more questions, please let me know. My students, you can write me an email, or if you're just watching on YouTube, you can put in the comments. So thank you for watching, and I'll see you in the next one.